When asked to solve a triangle and you're given three sides, SSS, the law of cosines is required to solve the triangle and find the three missing angles. In this video, we'll solve the triangle shown on the screen using the law of cosines. The law of cosines states that a squared equals b squared plus c squared. Looks a lot like the Pythagorean theorem, at least those first terms do, but there's an extra term subtracted on the right side of the equation, minus 2bc times the cosine of angle A. The Pythagorean theorem only applies to right triangles. The law of cosines can be used for any triangle. On the left side of the equation, I have a squared, and on the right side of the equation, I have the cosine of angle A. Now, across from angle A is side A, across from angle B is side B, and across from angle C is side C. The law of cosines can actually be stated three different ways. The first way the law of cosines can be stated is what is on the screen now, which is in terms of side A squared, but we can also state the law of cosines in terms of side B squared. And when you do that, the other two sides on the other side of the equation will be A and C, and the equation will end with the cosine of angle B, that same side, the angle across from the side that was squared on the left side of the equation. Could also state the law of cosines in terms of c squared, and in that case c squared would be equal to the sum of the other two sides squared, a squared plus b squared, and then minus 2ab, and end with the cosine of angle C. Again, the angle that's across from the side that's squared on the left side of the equation. To solve this triangle, we're going to have to find the measures of the three angles. And it doesn't matter which angle we find first. You could find angle A, B, or C first. Doesn't really matter. I'm going to find angle A first. I'm going to find angle A first. And of the three versions of the law of cosines that are on the screen right now, only one of them includes angle A, and that's the top one. A squared equals b squared plus c squared minus 2bc times the cosine of A, and that will be the form of the law of cosines that I'll use to find angle A. Now I'm going to have to use another form of the law of cosines to find the other two angles, but to find angle A, I'll use a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Substituting 26 for side A, 11 for side B, and 19 for side C yields 26 squared equals 11 squared plus 19 squared minus 2 times 11 times 19 times the cosine of the unknown angle A. 26 squared is 676. 11 squared plus 19 squared is 482. 2 times 11 times 19 has a product of 418. Now I want to isolate angle A. I want to isolate the cosine of angle A in this equation. So next I'll subtract 482 from both sides of the equation. And 676 minus 482 is 194, which is equal to negative 418 times the cosine of A. Next, I'll divide both sides of the equation by negative 418. So on the left side of the equation, I have 194 divided by negative 418. I'll leave that as a fraction, but put it in lowest terms. 194 over 418 in lowest terms is 97 over 209. This means the cosine of angle A is equal to negative 97 over 209. This is a trig equation. The unknown is the angle that we're taking the cosine of. So if I want to know what angle A is, I'll have to do the inverse cosine of negative 97 over 209. Angle A is the inverse cosine of negative 97 over 209. And that is, at least to one decimal place, 117.7 degrees. Angle A is 117.7 degrees. Next, let's find angle B. Again, I'm going to find angle B next, but I could find angle C next if I wanted to. The order that you find the measures of these three angles doesn't matter. I'm going to use the law of cosines again to find angle B. And of the three forms of the laws of cosine, only one of the forms includes angle B. On the screen, it's the second form that I have listed. B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. And of the given information, I'm given side A, side B, and side C. So in this equation, I'll be able to substitute a value for each occurrence of side B, side A, and side C, leaving the only unknown in this equation as angle B. Substituting a 26 for A, a 19 for C, and an 11 for B yields 11 squared equals 26 squared plus 19 squared minus 2 times 26 times 19 times the cosine of angle B. 11 squared is 121. I can do 26 squared plus 19 squared and add those together, and that sum is 1037. And then the product of 2, 26, and 19 is 988. The steps that I'll use to solve for angle B here are very similar, really the same steps that I used when finding angle A. Next, I'll subtract 1037 from both sides of the equation. 121 minus 1037 is going to be a negative number, negative 916, and that's equal to the negative 988 times the cosine of angle B. Next will be a division. I'll divide both sides by negative 988, and I'll leave this as a fraction. I'll leave the quotient negative 916 divided by negative 988 as a fraction in lowest terms. A negative divided by a negative is a positive, and in lowest terms, 916 over 988 is 229 over 247. So if the cosine of angle B is 229 over 247, then angle B would be the inverse cosine of that fraction, the inverse cosine of 229 over 247. And the inverse cosine of 229 over 247 is, to the nearest tenth, 22.0 degrees. Angle B is 22.0 degrees. Now it makes sense that angle B would be a lot smaller than angle A because the side across from angle A is 26, the largest side in the triangle, and the side across from angle B is only 11, the smallest side in the triangle. In any triangle, the largest side will be across from the largest angle, and the smallest side will be opposite the smallest angle. That only leaves us with side C to find to complete our solving of this triangle. We could find the measure of angle C using the law of cosines and the same method that I used to find angle A and angle B. If you wanted to do that, that would be a way to perhaps check your answers for angle A and angle B, because a property that all triangles have is that the sum of their angles is 180 degrees. Instead of using the law of cosines to find angle C, I'll just use that property. If angle A plus angle B plus angle C is 180 degrees, I can find the measure of angle C using this formula, since I already know angle A is approximately 117.7 and angle B is approximately 22.0. Those are both rounded to the nearest tenth. So angle C would be 180 minus 117.7 minus 22, and that difference is 40.3 degrees. So now that I have a value for angle C, I've solved the triangle. It is true that in any triangle, as I stated earlier, the largest angle is across from the largest side, the smallest angle is across from the smallest side, and the angle with the middle measure of the three is across from the middle length side. That is the case in this solved triangle, so I know at least my answer makes sense. And now I've solved the triangle.